Okay, here we are at the end of chapter 9. This is the last section. And we're going to start talking about reference angles. Reference angles are something that comes up on your calculator. Your calculator can't come up for every possible angle in the world. There are an infinite amount of angles. So the calculator is going to refer to an angle, and then it's up to us to figure out which one did we really want. So for example, right here, we're telling you that the sine of some angle is 0.9. Now this means that if I were to draw a triangle over here on my unit circle, the opposite side goes up 0.9. If I can get it there. But there are two positive 0.9s. There's another one right there. Now, I have to figure out what angle is that. Well, if I draw my triangle in my first quadrant, there is my leg, my hypotenuse. There is my hypotenuse. So there are my two triangles. So if I take out my protractor, as I had to do in high school, and I measure it up, let's see, open this up, and this looks to be an angle of about 64. So we think theta is 64. All right, and let's go do the other angle, because there are two angles right here. If I can get it. And this angle is 114. So which answer is it? Is it 64 degrees or is it 114 degrees? Well, it's both, till we figure out, well, which one did we want, and that's going to be based on the circumstances. But as of right now, what you're going to practice in tonight's homework is the fact that there are always two possibilities. Because in this case, sine is positive in two quadrants. And notice again our little all students take calculus. We knew that would have to be in quadrant 1 or quadrant 2 because sine is positive. And in quadrant A, S, that's where sine is positive. Now, let's use the calculator, because of course you are not going to be drawing yourself little grids to figure it out. What you're going to be using is the inverse function. I'm going to take the inverse of sine. Since sine is a function, we get rid of it by doing the inverse. So we're left with theta is found by taking the inverse of 0.9. So when we get out our calculators and we do the inverse of 0.9, look what we get. 64 degrees, because we'll be allowed to round it to the nearest whole. Awesome. But wait, the calculator didn't tell me both answers. It only told me 64. Where am I going to get the 114 from? You see, this was a reference angle. You have to figure out the other angle on your own. The calculator won't do it for you. Well, how do we figure that out? Okay, so we clean this up, and we're trying to figure out how big this angle is right here. Well, if I travel along my unit circle, I'm stopping right here. So we want to figure out how big was that purple arc I just made. How far is this? We have our reference angle. See, right here we learned that this is 64 degrees. So that means this arc is 64 degrees. So how much is this purple? Oh, I get it now. I do 180 minus 64, and that's how I get my other angle. And it's actually, when I subtract 180 minus 64, I get 116. So those are my two angles. This one was a little off because I measured it just based on my protractor. So these two angles were really 64 degrees and 116 degrees. And notice they add up to 180. Let's try another one. Let's say the cosine was 0.7. So that means I'm going to take my side and I'm going to go out 0.7 in the positive direction. And since cosine is the x value, I moved my line here along the x. And I went at 1, 2, 3, 4, 5, 6.7. If I'm going to create two triangles based on that, I have one triangle that goes here, and then one that goes down. So these are my two triangles. And I have to figure out how big those angles are. So the first angle is that one. And that's going to be pretty easy. Let's take our calculator and let's let the calculator do the work. So what I would be doing up here is I would be taking the inverse cosine to get rid of cosine and get theta alone. Cross off. Theta is found by taking the inverse cosine of 0.7. Awesome. Calculator. Inverse cosine 0.7. Okay, my angle's 46 degrees. So I found this angle to be 46 degrees. Great, but now I have to figure out my other angle. My other angle started here, traveled along this unit circle, and it stopped right there. How big is this blue arc that I just drew right here? Well, let's do some math. I know that I have a reference angle of 46 degrees. So I know not only is this 46 degrees, but this is also 46 degrees. So if I look at my blue magic marker here, what it is not quite a full circle. It's 46 degrees short of a full circle. So 360 minus 46 gets me 314. So those are my two angles. My angle could be 46 and it could be 314. Because if I take my calculator out, I can prove that. I can take the cosine of 46 and get an answer. And I can take the cosine of 314 and I get the same exact answer. Alright, here's a handy dandy little chart which you may want to copy. Some students have a problem with these reference angles, of figuring them out. So what we have here is a butterfly. No, I didn't come up with the name. See the butterfly? Or you gentlemen can call it a bow tie. And inside are how our four reference angles can help us find the actual angle. In the first quadrant, it's always just the angle that comes up on the calculator. In the second quadrant, it's 180 minus the reference angle. In the third quadrant, it's 180 plus the reference angle. And in the fourth quadrant, it's 360 minus the reference angle. So let's run through some practice problems here. Find to the nearest degree the two values. So we're always looking for two values in this practice section of theta. And theta is going to be somewhere between 0 and 360. All right, sine of some angle is 0.432. Well, I'm going to inverse sine, just like we did back in 8th grade. Mr. Labadie or Ms. Shahovska could have told you just to get an angle, we do inverse. So on our calculator, I'm going to inverse sine 0.432. And it's 26 degrees because we're allowed to round to the nearest whole. So this is going to be, let's clean all that up, 26 degrees. But, there are two answers. So since sine is positive, I'm going to look in quadrants 1 and 2, because that's where sine's positive. Okay, I found my reference angle to be 26. And then this would be 180 minus 26, because I know that this angle is 26 degrees, and that's 20 degrees, 6 degrees short of 180. So 180 minus 20 is 160. 154 would be our other angle. And you can check yourself on the calculator. You can take the sine of 26 and the sine of 154, and you'll see they get you the same answer. Cosine. I'm just going to reach for my calculator. Inverse cosine, negative 0.8402. Whoa, 147. Got some thinking to do here. So I came up with theta to be 147. Okay, where is cosine negative? Okay, cosine is negative in the third quadrant and in the second quadrant. But I can't put 147 inside a triangle. What this came back with is it came back with how far it was from here to here. This is one of the rare ones where it doesn't come back with a nice angle under 90 degrees. That's 147 degrees. And that's what we wanted to find. How big was this angle? Now, the next thing we wanted to find was the angle in the third quadrant. How big is it from here all the way to there? Well, I know from here to there was 147. So what I can do is I can kind of use a little knowledge. I can take that, whoops, take this blue one right here, and if I flip that, guess what? That's 147 degrees also. But since it's negative, so basically right here, it's 360 minus 147. So 360 minus 147 is 213. So the other angle is 213 degrees. That's a little tricky one, but you'll get used to it. Let's just do one more. Let's do this tangent one. We know to get rid of tangent, we inverse tangent, 2.9876, and our reference angle is 71. So we know our first angle is 71, but where are my angles? All right, let's do some math. Tangent is positive. Which quadrant is tangent positive in? The third quadrant and the first quadrant. So theta was 71. Great. Next thing I got to figure out, how far is it from here all the way to there. Well, I know that theta is 71, so 180 plus 71. See, I went 180 degrees, and then I went 71 more degrees. So 180 plus 71, 251.